So, the state of NLP. So, obviously, first question is, what is NLP? NLP stands for Natural Language Processing. It is a very broad term encompassing a lot of different areas of discipline. Really, to just fit into NLP, it is any kind of computational program that deals with natural human speech, whether that is in audio form or text-based. Now, NLP generally can be thought of falling into one or more of these particular categories. We have A to B, any kind of transformation. There's intent-based, where you are trying to figure out what the user wants to do from a natural language instruction. And you also have generative, which is creating new summarizations based on a bunch of different inputs. Generative AI has been a very big topic in the last handful of years. And just to give a little bit of overview of some of the things that you might be familiar with that fall into these different branches. We have A to B, that's going to be things like text-to-speech, speech-to-text, language translation as well, just like Google Translate. Generative, basic generation, like text generation. I'm going to train a model on the entire works of Shakespeare and just generate some new sonnets for me. You also have, and then just in the intents, you have these things called NLUs, natural language understanding. That's just an umbrella term for the actual decision-making part of Alexa, Google Assistant, Raza, if you're familiar with the Python version that can run locally for you. But then you also have other things that fit into multiple of these different categories. So between the transformation and the generative, we have things like image captioning and image prompts. You can think of that as text to image and image to text in that particular paradigm. But you also have things like style transfers, like take a piece of music, but I want you to take the audio from this and change the style to a country song. Think about image style transfer, take a photo, and I want this in the style of Salvador Dali, but for audio. You also notice I have GPT-3 and GPT-4, and in slightly different categories. I tended to not include specific models in here, but I did want to include these two, because the capabilities of individual models change over time, and that can change how they fit into some of these different categories. So GPT-3, which is what ChatGPT was running on until just a couple of months ago in preview, it only used text. But with GPT-4, it's now multimodal. So you can now have text, images, audio, and video as part of GPT-4, and it now moves into this generalized AI that covers all of these different capabilities. Even something like image prompts are a little fuzzy as well, because you can have something like Midjourney, which we'll look at a little bit later, and it's not really doing this kind of intent-based work. It's really looking for set keywords. People have figured out there's a very particular style of language, very particular keywords that these text-to-image models are listening for to generate the best possible results. But you have something like Adobe Firefly, where in it's a product from Adobe. It's doing a lot of that, but it also displays some intent-based iterations as well, where you can say, generate the following image. It generates it for you. Oh, remove the people from this image, and it will do that. It's some really cool things. Another reason why I didn't want to include specific models other than to point out GPT-3 and 4 is like I didn't want to put LLMs in there, because LLMs, large language models, that Matt was just talking about, are more than just the different topics in NLP. For example, language translation. LLMs, yes, they're just, in the simplest description, they are just trying to predict the next most likely word to follow based on what it's been trained and the context it was given. That's an understatement there, but that is essentially what they are doing. The way how those models are trained, the embeddings that Matt was just talking about, after all the training data, it allows meanings to be extracted from words in that vector space that do some really cool things with language translation that we haven't seen from other models yet. Think about Google Translate. If you put in something in English and you want to translate it to Spanish, if you put an idiom or a colloquialism into there, it's pretty hit and miss if it's actually going to just hear the words in the idiom translated to Spanish, or if it's actually going to catch on to the meaning. LLMs, because they use that vector space, are very, very good at figuring out the meanings of idioms across languages. So you can have a translation of English to Spanish that has a colloquialism or an idiom into there, and because this group of words that make up the idiom in these different languages are near each other in that vector space, that the 2D graph that Matt was showing earlier, they overlap with each other, and so the translation engine is able to go, oh, you mean this, and so you're not just seeing the words being translated in a colloquialism, you're actually getting translation of meaning across the languages. I will come back to language translation a little bit later because there are some issues that Matt did kind of briefly talk about that we'll have to get into specifics. But let's go on. I'm going to start with just some basic overview of a couple of the different things that were in that graph. And we're going to start with some of the A to B, speech to text, and text to speech. These are very well-baked technologies. Generally speaking, a lot of speech to text and text to speech algorithms are embedded into operating systems nowadays. They have been for a very long time. Think about the voice overlays for accessibility purposes. These have been on operating systems for many years, some going back to the 90s, as far as I'm aware. They may not be perfect, they may not sound very good, but they could do the job. For speech to text nowadays, by far and away the most accurate one out there is OpenAI's Whisper API. If you have an internet connection, use it. It's leveraging a lot of the web training data, where if you are listening for names, especially just names of new characters, we've looked at some IP-based things. The Whisper API is by far and away going to be the most accurate on some of these lesser used, newer terminology. And I also have speech recognition, and over there I also have PyTTS X3. These are things that you can just have pip installed into any project that's running Python. Again, they're all just there, and they're very easy to use. We also have text-to-speech, which is these are related technologies, but the underlying underpinnings of how they work are very different because for speech to text, you don't actually have to have an engine that knows how to generate human speech. You just have to have something that understands the waveform and extracts text out of. For text-to-speech, you have to come up with a language model that has a character to it. We've seen over the last 15, 20 years, we're getting away from very robotic sounding text-to-speech algorithms. They're getting very natural. You can have things like, probably Google Speech Synthesis is probably the easiest one to use. You can use it from any language, but in most cases it does require an internet connection. Although, if you have an Android phone, you have an offline text-to-speech and speech-to-text generator embedded in your phone. So we're also seeing a lot of consolidation, simplification for offline use, and that's going to be something we see coming back as the future of various technologies. There's also something from AWS called Poly. You can spend $500,000 and get a voice actor to come in, and they will create a custom voice model for you. It is incredibly detail-oriented, but I don't have it listed here. A lot of the focus in this particular area for text-to-speech nowadays is how can we build these voice models using very, very little training data. they still end up sounding pretty robotic because the less training data you have, the more, or the less information it has available to figure out certain sounds. But I do have something, and we'll see if it works later on, where you can take maybe a minute of audio from a video game character and can reasonably create a voice model that sounds enough to people who play the game to go, oh yeah, that's definitely that character, I know what you're going for. For text-to-speech, there's also this particular syntax here called SSML, speech synthesis markup language, where you can, it just looks like HTML, any other kind of these tokenized markup languages, and you can use it to have more fine-grained control about how the voice model should say the text that you give it. So for example, we have the say as, where if I want to do SSML, I am explicitly telling it to say the following characters as SSML as opposed to trying to pronounce that particular acronym there. You can add in things like breaks. There's also emotions and emphasis, some substitutions you can add in there. And a lot of these you can also add in just audio, and it generates an MP3 or a WAV format or whatever the output is for you to then use. Next slide. The next step up here is these intent engines. Natural language understanding. These are going to be things like Alexa, Google Assistant. And the point here is to figure out within a given set of parameters that you control, what is the user trying to ask you for? On the right hand of the screen, we can see here's a template that we might have for one of these intents. Make a reservation at such and such location for such and such date. You can think of intents as functions, and these different location and date, we call them slots in NLUs. These are like your function parameters. So if someone says, make a reservation at Seasons 52 for 6 p.m. next Tuesday, your code gets back, this gets mapped to intent.reservation.create, your location is Seasons 52, and here's the date time string that they asked for. Now you notice, 6 p.m. next Tuesday, that is a context-based disambiguation that these models are doing for you. There's a lot of built-in slot types that are very, very forgiving from a developer's point of view. So you'll have things like dates, numbers, movies, airports, just a lot of built-ins from some of these larger providers. So just kind of going through, we have Alexa, there's AWS Lex, which is an AWS service that is just the NLU component of the Alexa ecosystem. Alexa is an entire ecosystem. So if you want to get some of this NLU on your own personal projects, I would highly recommend AWS Lex. There's also Dialogflow, which was a Google acquisition a number of years ago. You can build Google Assistant skills using that. There's also Microsoft Lewis as part of the Azure Cognitive Services on the Microsoft side. There's IBM Watson, which is probably the earliest of any of these that you might recognize. And on the last one, there's a project called Raza, which is a Python install. And the cool thing compared to the rest of these is Raza you can run locally. So you can have it on your machine, you can run it on a Raspberry Pi, can have a completely offline voice assistant that you create. Now the main limitation before we move on compared to these large language models is you do have to explicitly tell the NLU what it needs to be listening for. We have make a reservation at location for date, and we could have a bunch of different examples, different utterances that someone could ask that maps to intent.reservation.create. But if someone says something that you have not explicitly told it to listen for, it's going to come back with a fallback and go, well, I don't know how to deal with this. And you don't tend to see that with some of the newer technologies. So it's this fine-grained control that you have with NLUs that you don't have with LLMs. Now, text to image is another area there. Again, like I said before, if you look on the right-hand side, this is not this is language, but it looks more like keywords. And these are things that people have figured out how to ask the models to perform the way that you want. It's kind of like an old school Google search, where rather than asking what time does such and such open, you would be trained, for lack of a better term, to ask Google based on keyword searches that were most likely to give you the answer that you wanted. I'd say that's an apt comparison here. However, Adobe Firefly, so DALL-E 2, this image is actually from Midjourney, by the way, but Adobe Firefly is one of the newer commercial options, larger commercial options, and they are, while they do text to image, they also are starting to have more of these large language model capabilities onto there that are going to make it really powerful. And large language models. And I'm going to call these context-based LLMs rather than just saying LLMs, because you can use LLMs, large language models, for a bunch of different applications. However, if you think about things like ChatGPT or Bing Chat, who in the world would have thought we'd be talking about Bing as a center of productivity and innovation in 2023? No. Now, Bing Chat is using OpenAI under the hood. They have a very public partnership, and I swear it has gotten better since Google's introduction of Bard a couple of months ago. But Bard is also there. Google I/O earlier this month really showed where, at least I think personally, the next steps for these large language models are going to go. And we also just saw another version of that today with Microsoft Build. And cool, we have these large language models, these context-based large language models. They can do some really interesting things. Most people are not going to go to chat.openai.org and interact with it there. It's going to be coming up with the context that actually makes it useful, embedding it in applications in your everyday life. So Google showed off things like, based on my email history with this person, I need you to write an email response that I am accepting this offer that the person has given me, and it will do it for you. Those are the kind of things that I can see for most people. That's how we're going to interact with these kind of large language models in the future. It's going to be more managing the context, managing the vector databases that Mac was talking about, because until plugins were announced just recently, went live just recently, being able to control what is in the vector database, that embeddings database, that is where you're going to be able to inject new information outside of the context that sets up your various interactions with these large language models. For example, there is a company called Cape Privacy that is trying to tackle one of these really interesting problems with security, especially around corporate data. And what they're doing, they have a system where you'll be able to obfuscate information that goes into the vector database. But the cool thing about the vector database, that embedding space that Matt was talking about, is even though the information is obfuscated, it doesn't lose the meaning in the vector database, in that embedding space. So you can still train a large language model on the context of your entire business with all of your customer data, and you're not losing the actual names, addresses. There's not a chance that it's getting leaked to OpenAI or it might get out. Because by the time that it leaves your private, by the time that it leaves your private cloud, it's already been vectorized. That information isn't in there. The language model does what it does, it comes back with the answer, and then you can optionally de-obfuscate it depending on the access levels of the end user. So we're going to see some really interesting use cases like that. I think after this, we go into a slight change. Are there any questions on just a couple of these different topics so far? CAPE privacy, C-A-P-E. Yeah. It's, I don't think that is, no, I think they do have a demo on their website right now. Part of that is going to be a little bit less needed because we're seeing more of the desire for these cloud providers of these large language models to be able to provide secure enclaves for a lot of data, especially sensitive enterprise data. We're seeing that from Microsoft. They just officially announced today that they're going to have AI studio spaces that can be completely contained within a company VPC. That's going to alleviate a lot of lawyers and security professionals. Any more?
What do you think about where we've gotten to with ChatGPT? Because that was kind of a big shock and wow factor for everybody. And where do you think things are going? I know this is a hard question, but
Well, actually, I think let's go to the next slide. Because I think yes, here we go. So funny you mentioned that. This was a lovely image that I pulled off of LinkedIn. I can look up the poster that I pulled this from at some point. But it kind of shows you GPT or ChatGPT and these large language models, they didn't come out of nowhere. ChatGPT was a novel way for people to interact with them and get a lot of usage out of them. And they also made it slowly more open over time, which got more people to try it out. You can see Lambda right here from Google. That was at least announced and created at the end of, or at the start of 2022, but no one had access to it because, well, Google, I would say rightfully saw that it wasn't quite ready for public consumption. And then ChatGPT came out towards the end of the year, and we saw that there were limitations with it, but people had access to it now and could get really excited over it. This chart only here goes back to 2018. But at the very bottom, we have a library called Word2Vec. That came out in 2013, and it is the core underlying library project implementation, have slashes between all of that vectorized language, text language. So a lot of the improvements that we've seen in the NLP space as far as text-based learning goes really can come back to Word2Vec in a lot of cases. We saw a lot of technology take off after that, but to kind of bring the whole thing home, only going back 5 years, that's when we saw, okay, we have encoder only, encoder, decoder only, as these various types of transformers that branched out in these separate directions. Some of them took off. Like we had things starting at the same time. So you can see GPT-1, the very first version of it goes back to 2018. But we also had Elmo Ernie not too long after from a bunch of different companies exploring this space. And arguably, I would say the winner is this decoder map on the left-hand or the right-hand side there, because that's where we're going to find most of the things that people recognize nowadays. Obviously, you have Bard and GPT-4 on the top. ChatGPT is lineage from over here from Codex. There's Lambda in there as well. The newer versions of things like Ernie are also in that space. But it's only 5 years old to when we started working with these transformers, and it's only 10 years old before you get back to Word2Vec, which really kicked a lot of this into gear. So from a future point of view, we'll talk about that later, but you kind of see this as the way things are going. And Sam Altman, he also was saying things like, okay, we've gotten to this point, we know where this can go, but the future is not making these models any bigger. It's going to be figuring out novel uses for them, I would argue figuring out how to simplify them. I think we also have Llama from Meta in there as well somewhere. There was also a project out of Stanford called Alpaca, which I mentioned at the tail end of Matt's Q&A there that it took $4.6 million in just compute time over 34 days to train GPT-4, whereas Alpaca from Stanford was trained in a fraction of the time with $400. There are some legally dubious ways that they did that, because they didn't train it on the source data. They trained it by interacting with other pre-trained LLMs. But there is a stark difference, and it's also not quite as accurate as the larger language models, but there is a stark difference between almost $5 million and $400. So I do want to, the next step is just kind of talking, giving a couple of examples about how different areas of NLP can build off of each other to make new and interesting things. Wanted to talk with to start with what's the most obvious example that people are familiar with these days. Any kind of voice assistants. Ours is a combination of 3 NLP technologies. Starting with the user, your typical loop is going to start with speech to text, including language detection, because once you get to the NLU, you actually have an individual model for each language that you support. So part of speech to text is also detecting what language that the NLU should use. We get into the NLU, so you're identifying those intents and slots, and on top of that, you also have models that are specifically designed to know which skill to forward your request to. Think about how your Google Assistant can answer just about any question under the sun. There's a bunch of different layers that it is going through to figure out, is this something that Google itself knows how to answer, or does it need to go to a third-party service? Well, if it's something Google does, which of these branches does it go to? And then it finally gets to a service backend where you can have all of your service logic, and you finally construct the response that gets sent to your text-to-speech, where you're using SSML and any other kind of voice model that either you choose or the user chooses to finally send a response back. And we've seen that technology take off over the last decade. It kind of hits a wall, but it is still changing all the time. And that's kind of by design. Another example, I wanted to pull this out, is something that's really a cool use for NLP, combining NLP technologies. There's a company called Supertone. They were acquired by Hyde, a record label. I think they do BTS. I forget it. They're a big one though. Supertone is a technology incubator in the audio space, the music and audio space. One of the things that they were able to do is one of the papers that they published was, how can we take the text, tone, and melody from various songs and translate them into other languages while retaining the meaning of the words and the melody of the song. And this company is also based out of Singapore, I believe, so they also specialize in things that we are not as familiar with, things like tonal languages, which is particularly difficult when it comes to an audio translation, for example. So in this particular image, we all know, I'm singing in the rain, and you can see that mapped out on the very top one. Well, your singing is going to be slightly different than how you would naturally say the same words, and that's going to be completely different. And languages are going to be completely different, especially tonal languages, when saying the words of an applicable translation of the same words. So how can you take those differences and generate something that is reasonably similar? This image is from a paper from March of last year, but just recently, this company, through the music label, released a song in 11 different languages, and the lead singer only spoke one of them. And they were able to do it keeping the same meaning in the words, roughly the same melody throughout, and they were able it's some really cool things. Like, we think of a lot of things of NLP, we have all of this text-based stuff. There's a lot of really cool things happening in the audio space as well, especially in music. We're very keyed into music. We know when music doesn't sound right, and the fact that you can have simultaneous release in 11 languages and your speaker only saying one of them is really cool to me. This was the other thing, and we'll see if the sound works on this, but this is something else that was recently released. This is a mod for Skyrim that combines speech to text, ChatGPT, and one of these text-to-speech models that is designed to use very, very little training data. Let's see if this works.
So were you ever told campfire stories?
Let me think. Yes, my family and I used to tell campfire stories during our hunting trips. We would share tales of great Nordic heroes and legendary creatures such as trolls and draugr. I remember once my father told us a story about a warrior who battled a powerful dragon and emerged victorious. It was a thrilling and inspirational tale that instilled courage in me and my siblings.
Recognize that the voice is close
It's a house call.
to Lydia, and you can have an arbitrary conversation with. Further on in the video, he has a bunch of different examples from characters in Whiterun that you can do this to. It's context aware. It really is just setting up the context that goes into these LLMs. You provide as much information as possible. It updates the vector database for the remainder of your questions, and then you can just have a conversation with a known character in a video game. I think it's really cool what a lot of these modders are doing. Now, of course, there are always some problems in any text space. Now, a lot of the issues that we have right now in the NLP space match a lot of the same kind of concerns that you would have in larger generative AI and machine learning spaces. These are just a couple of the different categories that we are thinking about. Legal is always a concern. The particular image I have here for that is it's very hard to prove, or well, let me put it this way. There's a larger issue going on about how to create data sets for all of these different models. There's issues around IP, there's issues around sourcing, weights. Is the information even correct? How do you vet it properly? And we can think about artists where they're still living, they're still making money, and these models come in and go, oh, I want you to make it in the style of this artist. Well, where did they get the knowledge, or where did these models get the knowledge of how to do something in that style? In this particular image here, you can see, well, this is a generated image, and it has put in the Getty Images watermark, which is very clearly against terms of service. This is one of those the clearest cases that we have right now in the courts of was the data set, or does the data set include infringing information, controlled IP? And it's very hard to argue with that. There are always ethical concerns. Legal and ethical are going to be the two biggest issues in just about any kind of talk when it comes to machine learning in general. This particular image here is of a South Korean singer who passed away a number of years ago. However, in 2021, the record label trained a model on this singer's voice and put out new singles in 2021. We can think of other areas where this might be legally dubious. Think about Disney basically controlling actors' like voice and likeness in perpetuity to keep creating new content. I would say most people in here probably saw, what's the start? Rogue One. Well, we had Carrie Fisher, and we also had Moff Tarkin in there as well, both of whom have passed away, but likeness and voice were reconstructed. And this is back in 2016, I think. The capabilities have only improved since then. There's always an issue of accuracy as well. This is something that has been a little more on the forefront when thinking about things like ChatGPT. This particular example was from the oh so graceful Bard rollout. If you remember, their media department put out some examples that Bard was able to produce, including this little ditty about was it a telescope or a planet or something, and it very clearly put out information that was wrong. Now, the model doesn't know that it's wrong. It's just trying to predict the next best word. But the fact that it also, not only did it do this, it got through every approval branch in order to actually get published as an example on launch day of what your model can do. Yeah, humans are very trusting when it comes to computers, and that's a known thing. It's like, oh yeah, this is summarized, this must be correct. Anyone who has used a code writing tool like Copilot or anything from GPT, the more complex it gets, the more likely it is not able to run at all. You'll know what I'm talking about there. Although there have been some really interesting improvements. I know Matt had that example of GPT 3 to 4 where it was less correct. The accuracy of the answers that GPT-4 puts out in aggregate is about 40% more likely to be correct, which is a huge improvement, even if we do continue to see variations in the different answers that we're given. And of course, sustainability is always an issue with these large models as well. $5 million to train. What is the ongoing cost of actually continuing to run these models? That's also a big concern. Now, when it comes to things like accuracy, the legality, and ethics, it really comes down to the training set that you have. What does your data look like? And there's one thing I really want to get across, is there's no such thing as an unbiased data set. The mere act of determining what should and should not be in a data set is bias. It introduces bias. We're all biased individuals. Even choosing to include every bit of information is a bias, because bias exists in the world. There's an entire field of data science devoted to trying to minimize bias, but you can't, minimizing one set of bias increases another type of bias. It's really cool, it's really insane. And some examples of that we kind of talked about earlier is language support in these large models. This is the information that GPT-3 was trained on. These are public data sets. The biggest one that you can see, weighted 60%, but in terms of content, has way more than anything else, is a data set called Common Crawl. It's from about 8 to 9 years of internet data, text-based internet data. The final mix of languages that went to train GPT-3, English makes up 90% of that. And then every other language is just a decreasing part of 10%. Now, large language models are really good at translation, but because English is so heavily weighted, you can see the graph over here, those top bars that overlap, that is the accuracy of translation from English to French, German, Romanian. The 3 on the bottom is trying to go back the other way. So we're going to see, we see a lot of issues when it comes to, if that's how it works with translation, you can imagine the slightly the degraded experience that people have trying to use something like ChatGPT if they're not an English speaker. That goes back to this whole availability of these tools, whether it's paid or just bias built into the training set where it is just less useful. Another example of where your training data really matters in NLP is image captioning. Now, this is actually known as the everything is awesome problem. insert an image of the Lego movie or Benny here. We see an image like that on the right-hand side. Oh, it's a lovely sunset. Well, if we wanted to caption this image, we might want it to say something like, oh, it's a photo of clouds at sunset reflecting over mostly still water with mountains in the background. That's a pretty good description of this in terms of what you are actually looking at. If you are just getting from a public scrape of the internet, you're probably going to get something like, oh, it's such a colorful end to an amazing day with my friends. Think of something you might see on Instagram. The problem with data sources like this is we are seldom actually describing what is in the image. We are describing our experiences that the image represents. And that's a problem if you don't consider that and you get an image like this. That's a problem. We don't want it to say that. And you can see how that comes, again, that is very, ethically dubious. That is all, you're also going to get into some legal hot water if that's what it puts out. So those are some of the problems that we have. What is the future? Well, I can tell you that unless we look back at the graph and kind of see where things have been going, it's kind of hard to predict exactly what the future is going to hold. We can look at what has happened in the past at other technologies, some of the underlying layers. Deep learning has been around since the 70s, 80s in terms of its mathematical underpinnings. But we didn't really see deep learning take off into a technology that's commonly used until we saw GPUs improve for computer graphics. And it just so happens that if you take a 2D screen and really improve the refresh rates on that, well, that maps really well to a neural net and all of the weights. Eventually, you have your phone now. A lot of these machine learning models, regardless of the architecture, we now have cores built into your CPU that are specifically designed to run some of these models. So a lot of that text-to-speech, speech-to-text, image recognition, image extraction, a lot of that stuff is built into your phone now. It runs completely offline, and it's pretty energy efficient, all things considered. We have a long way to go for that in a lot of other NLP spaces like large language models, but that is probably where we're going to see it go, in addition to a lot of really interesting and novel combinations with other technologies. We do still have a long way to go. I mentioned in sustainability, there's a lot, we have to think about how much electricity that these models are using, just not only for training, but in general operation. On average, a call to ChatGPT uses the same amount of electricity it takes to charge a phone 50 times. So it's going to have to get a lot more efficient before we can actually put something on a phone to do the same. But, kind of like what Matt was talking about, we just need to keep thinking of new and novel ways to use this. It becomes more efficient, and over time, through either advances in compute or novel ways of doing the exact same task, we can get it to putting in more places. And that's it for me. I think just one more overview slide. You can get me at mdupont on the ODev Slack. I'm always listening in the Python channel because, again, I run the Orlando Python developers. You can find me on LinkedIn, or you can also go to our meetup at pyorl.org. That takes you over to the meetup page. You can also see a lot of our past talks on YouTube. Just search Orlando Python. That's it.